Okay, so today we're going to talk about what an inverse matrix is and what you can do with an inverse matrix. Okay. So first of all, we defined what a square matrix was, right? The same number of rows and columns, and I told you that square matrices were special. Okay, here we're getting into what is special about a square matrix. Okay, so an identity matrix is a square matrix, same number of rows and columns, that consists of ones along the main diagonal and zeros everywhere else. Okay, sort of sounds familiar. But now we're not talking about an augmented matrix that represents a system. Okay? Now we're just talking about normal matrices. There's no dots. There's no representing of an equation. It's just a matrix with numbers inside. Okay? So a square matrix that has ones along the diagonal and zeros everywhere else is called an identity matrix. So this right here is the identity matrix for a 3x3. Okay, you see the ones along the diagonal, zeros everywhere else. Okay, I want you to flash back to man, I don't know if this is maybe like 5th or 6th grade math or if it's 7th or 8th grade. I don't really know where they teach this anymore because things have changed a lot. But you talk about 0 and 1 being important numbers when you talk about multiplication in addition, right? The number 1 is the multiplicative identity. Why do we call 1 the multiplicative identity? What happens when you multiply by 1? You get the same number, right? So when we talk about an identity matrix, it's that same sort of thing. If we take a matrix times the identity, we're going to get the same matrix. The identity matrix is like multiplying by 1. Okay? So if we take a matrix times the identity, in any order, we're going to get that same matrix. Okay? We can have an identity matrix of any square number. So we can have a 2x2 identity, a 4x4 identity, a 10x10 identity if we wanted to. Probably won't work with that one, but we could do it. Okay? Now, we needed to talk about that so we could discuss what an inverse matrix is. Okay? So, if A is an n by n matrix, and I, see how we call it I is the identity matrix. If there exists an inverse, okay, notice how we say if, it's not a guaranteed. If there exists an inverse, then A times A inverse is the identity matrix. Or A inverse times A is the identity matrix. Okay? If a matrix has an inverse, then when we multiply them, we get the identity. It's sort of like taking 2 times 1/2 and 5/2 times 2/5. When you multiply those two, we end up with 1. Okay, it's because we're multiplying those reciprocals. It's that same sort of thing. A matrix times its inverse multiplies to be our identity matrix. Okay? Now, we are going to focus on inverse matrices. I need to point out that if we have a non-square matrix, it cannot have an inverse. We're not even going to try. It's not going to work. Only square matrices can have inverses. However, not all square matrices have inverses. It is possible to be a square matrix and not have an inverse. Okay? So square matrices are special, but only some square matrices are even more special to where they have an inverse. Okay? And we'll talk about things here as we go along, how we know if an inverse exists or not. Okay? So you have a formula right below that. Okay? This is how we find the inverse of a 2 by 2 matrix. So notice how we have a matrix with entries A, B, C, D. Okay? This right here, AD minus BC. What I want you to notice is how those are paired up. A gets multiplied to D, and B gets multiplied to C. So we kind of make like a crisscross pattern, would you agree? Okay. As lame as this sounds, I like to remember this as criss minus cross. Okay, we make a crisscross pairing up our entries, and we subtract the products. So we have 1 over criss minus cross. Okay, it's lame, but that's how I remember it. If it works for you, use it. If you want to use something else, you go for it. Okay, now do you notice how these are different? These entries in here. Okay, what happened right here? Okay, so A and D, the ones we've already paired together, switched places, right? Okay, so these switched. What happened with these right here? Okay, but did they stay where they were originally? Okay, they stay, but we throw a negative sign in front. We negate them. So we take 1 over criss minus cross, we switch the first diagonal, and we negate the second diagonal. Okay, I want to point that out. We're going to find a lot of inverse matrices today between our notes and the homework. Hopefully this will become your second nature to you. Okay, but by the time we get to Friday, you need to be able to do this inverse formula without looking at your notes. Okay, that would be the goal. So let's go ahead and look at this matrix right here. We have a 2 by 2 matrix. That's what we just have our formula for. Okay. When we find our inverse, we need to take 1 over criss minus cross. So what's our first diagonal product? What's this product right here? 6. Write your minus sign. Okay. It is possible that we're subtracting a negative number, not in this one, but it is possible. So always write it so you don't forget. What's our up diagonal product? 2. Okay. And then what we need to do is we need to switch A and D. We're going to switch that first diagonal. And then we need to negate the other diagonal. So -1 and -2 actually become positive. Well, what's this number right here? 1/4. We have 1/4 times this 2 by 2 matrix. Okay, so just like we did Friday, we're just going to multiply it through to each entry. So we have 1/4 times 2, 1/4 times 1, 1/4 times 2, and 1/4 times 3. Okay. Now I wrote really big. Okay. I'm going to go ahead and show you something. If you have room in this area, I'm going to do a very good job. I'm just going to do it. I'm going to have to do it up here. Okay. Now, what did I tell you about a matrix and its inverse? When we multiply them, what should happen? They kind of cancel to equal the what matrix? The identity matrix. Okay, which is kind of like a 1 in matrix world. Okay, so if we take 3, -1, -2, 2, and we multiply it by its inverse of 1/2, 1/4, 1/2, 3/4. Okay, let's see what we get. Okay, row times column, we get 3 times 1/2 plus negative 1 times 1/2. Okay? Row times column. We get 3 times 1/4 plus negative 1 times 3/4. Okay? Row times column, we have negative 2 times 1/2 plus 2 times 1/2. And row times column, we get negative 2 times 1/4 plus 2 times 3/4. We get 1, 0, 0, 1 for our matrix. Okay? That's how we know that we found the inverse correctly, is because when we take A times A inverse, they multiply to be our identity. Okay? Now this is what I was trying to get us to find. But I know that, well, first of all, I want you to understand what the heck we just did. Okay? Second of all, it's probably going to be a problem in your book. Okay? Find the inverse and make sure it is the inverse. When we take A times its inverse, we get the identity. If we did the commutative multiplication, which we already talked about, matrix multiplication is not commutative. However, if you have a matrix and its inverse, no matter which way you multiply them, you will get the identity. All right, how about you go ahead and set this one up for me? Set up the inverse here. When we take 1 over Chris minus Cross, what do we get for that first product? Minus. And just real quick, just for the practice, what entry goes right here? And what entry goes right here? Okay, we switch along this diagonal. What entry goes right here? Positive 1, and here? Positive 6, because along this diagonal, we negate the signs. Okay, what is the issue?
It's 1 over 0.
It's 1 over 0. Can we divide by 0? Okay, this is a problem. When this happens, it means that no inverse exists. We can't find it. Okay? We can't take 1 over 0. And we said not all square matrices have an inverse. Okay, here is that case. This matrix does not have an inverse. That's okay. Okay. Unfortunately for you, the method to find a 3 by 3 inverse is way too intense. Okay? You can save that for college, or just whatever, do it all. In this class, in Honors Pre-Calculus, and Mrs. Holman, Ms. Cronky, whichever teacher you have, anytime I ask you to do a 3 by 3 matrix, find the inverse, you have to do it with a calculator. Go ahead and get that out. Okay. On your notes sheet, it has instructions that we'll go through together, but do you see this example down below? That's the one that we are going to find the inverse of. Okay, but I'm going to pull my calculator up here, so it's going to hide it. Okay. All right, so just like we did, I don't even know what day we did it. Was it Thursday? We need to go to our matrix menu. Remember, second, x to the negative 1. And we need to edit our matrix. What order of matrix do you have right below? a 3 by 3. So go ahead and change matrix A to be a 3 by 3 matrix and punch in the entries. Does everybody have their Okay, so here's where it gets exciting. Go ahead, second quick, back to your home screen. All right. So here's what we need to do. We need to find the inverse. Okay? Whatever matrix you just edited. I did matrix A. Did you do matrix A? Probably, more than likely. So go ahead, in the matrix menu under names, bring up matrix A into your calculating screen. And then we want the inverse, which coincidentally is the button we use for our matrix menu. We just don't have to press second. You literally just press that inverse button. Now, let's see. I'm going to just change one number to C. Okay. I changed my matrix so it looks different. Do you see how I have decimals and I can't see them all? If you have decimals in a matrix, please change them to fractions by punching this math button and this number 1, just pressing enter. It's going to take your answer to be fractions, and then you can actually see what they are. Okay? Math, fraction, enter, and you have a fraction where you can understand them. I changed an entry, and so I found an inverse of a different one. Okay? That is not the inverse you should have. I changed mine so I can show you that on my calculator. Okay? Your inverse should be the negative 13, 6, 4, 12, negative 5, negative 3, negative 5, 2, 1. So if you haven't already, go ahead and write a inverse on your notes sheet. Yep, this one right here. Okay, now, some of you really love elementary row operations. Some of you really enjoy the puzzle aspect of being able to do that. Oh, that's because Okay, so some of you love elementary row operations using the augmented matrix, going from there. Some of you really don't enjoy it. Okay, I would like to present you with a second method on how we can use matrices to solve a system of equations. Okay? What we're going to do is we are going to set up a matrix equation. So if you put this into an augmented matrix, erase it. That's not what we're doing. Okay? Instead, we are going to use an equation of three matrices. Okay? Equation or matrix number 1. Take the coefficients of your variables. So 1, 2, 2, 1 came right here. 1, 2, 2, 1. Just take the coefficients. Okay? Our second matrix is our variable matrix, x, y. If I take this matrix and I multiply it by the matrix x, y, we would get 1x plus 2y and 2x plus 1y, which is what our equations are. Okay?
Why don't we repeat the same?
We got nothing.
Sorry.
These need to equal the 7 and the 8. Is that better, Katie? Okay, so we have a matrix equation. Now, I'm going to go ahead and give these matrices names. I'm going to give this name X, or excuse me, A. Our variable matrix, I'm going to name capital X, and then I'm going to name this matrix B. Okay? Well, in numeric world, how would we solve for X? If we have A times X equals B, how would we solve for X? We would divide by A. Okay, have we talked about dividing by matrices? No, that's not a thing. Okay? However, dividing and multiplying are inverse operations. Would you agree? So instead of dividing, we can take A times X equals B, and if we want A to leave, what could we multiply A by? A inverse. We know that A inverse times A is the identity. Well, if we multiply A inverse to one side, we have to multiply it to the other side. So A inverse times A is the identity matrix. And we know that the identity matrix times anything is just itself. So it really just cancels out. Okay? So if I want to solve for X, we multiply A inverse to both sides. These cancel out to the identity, and we're really just left with X. Okay? So what we can do, we can find our A inverse matrix, and then just use matrix multiplication. Okay? So let's do that. Let's take A inverse here. Let's see. Okay. So we have 1 over, this first product is 1, minus our second product is 4. Times, we switch A and D. Real exciting, right? They're both the same. Okay. And then we negate B and C. All right, so what does that make our inverse matrix? Okay, this is just 1 over negative 3, correct? So we have negative 1/3 times 1, negative 1/3 times negative 2, negative 1/3 times negative 2, and negative 1/3 times 1. Okay, there is our inverse matrix. Okay. All right, so we're going to do this step right here. What's A inverse times A? The identity. They cancel out. I'm not going to show that. That's multiplication we don't need to do. All right, so we know that X equals A inverse times B. all we have to do is multiply. So let's just process what we did. We found our inverse. We multiplied it to both sides. The A canceled out. And now we just have A inverse times B to multiply. So help me out. First of all, this is a 2 by 2 matrix, and we're multiplying it to a 2 by 1 matrix. Can we do that? Okay, good. We better be able to. And what is our product going to be? What order of matrix? Okay, we're going to have a 2 by 1 matrix left over. Okay, that's good because that's what x and y equal. Okay. And I'm going to come over here just for effect. I'm going to call this xy. Okay. Instead of calling it capital X, I'm going to actually put my matrix in there. Okay. Do you see how all of these fractions have the same denominator? Okay. I am not going to simplify any fractions until I get to the end because right now they have the same denominator, and when we add them together, we want common denominators. Okay. So row times column, negative 1/3 times 7 plus 2/3 times 8. Okay, there's our first entry. Row times column, 2/3 times 7 plus negative 1/3 times 8. Okay, help me out. Negative 7/3 plus 16/3. And 9/3 is the same as? (14/3 minus 8/3? 6/3, which is, okay. So the coordinate of intersection for our two lines is the coordinate 3, 2. Some of you really like row operations. Some of you may not. Now you have choice. Okay? You can either do row operations to get it into row echelon 4 and figure out what x and y are, or now we can do a matrix equation and use the inverse. Cool. Questions before we do our last example? Yeah.
Is there a way to check your answer for this?
There is always a way to check your answer when we are doing a system of equations. So we got x is 3, y is 2. Is 3 plus 2 times 1 equal to 7? Well, maybe I should actually do the right coordinate. Is 3 plus 2 times 2 equal to 7? Is 2 times 3 plus 2 equal to 8? Okay, good. So we got the right xy coordinate. Okay? All right, now, if we are going to do this with a matrix equation, okay, how about you go ahead and write the matrix equation for me? Just like we did with our 2 variable 1, okay, not an augmented matrix, but the coefficients times the variables equals the constants. You need 3 matrices, just like we did in the previous example. Okay, so this is what you should have, right? Okay, now, this is a matrix equation, and we would have to solve it just like we did earlier. However, okay, so instead of dividing by A, we have to multiply by A inverse on both sides so that we can get A inverse and A to cancel out. So just like in the previous example, we need A inverse times B. What did I tell you about a 3 by 3 matrix? So what we can do, we can plug A into our calculator under A. We can plug B into our calculator under B. And then we can take A inverse times B. So let's go ahead and do that. In your calculator, edit A to be this 3 by 3. And edit B to be this 3 by 1. Okay, and I'll do that at the same time. Edit B to be our 3 by 1. Okay. In our calculator, how we type it in is important. Since we had to put A inverse on the left side, we have to put A inverse on the left for the other side of the equation. Okay, so we would need to call up A inverse times B. And so our coordinate of intersection is 2, -1, -2. Yeah? Is anyone else saying that? Okay, let's go up to go to matrix A for me. You have 2, 3, 1 for your first row. 3, 3, 1 for your second row. 2, 4, 1 for your second row. Okay, go to matrix B for me. And in matrix B, do you have -1, +1, -2? That will be the difference. Okay, Veronica? Okay. So we now have lots of choices. Okay. We know that we can solve systems, elimination, substitution, graphing. Okay, those algebra games. Okay, we have those options, but now we also have an augmented matrix with row operations and an inverse matrix that we can use with a matrix equation. Okay. All right, we have about